second derivative. Unfortunately for you, usually when we get to the last topic, it's like the hardest thing in the unit. I'm sorry, this isn't very hard. I pre-apologize for ending with something easy. Okay? Here's the notations for the second derivative. I'm not going to tell you what it is yet to ruin all this fun and excitement. We'll first look at notation. You have two ticky marks to go f double prime, y double prime, d2y by dx squared. Leibniz notation, which, like, why do you put the 2's in different places? Well, I guess part of why you put the 2's in the different rotation is to learn what is the second derivative. It's just doing the derivative again after you've done the derivative once. Okay? So, if you can do the first part of this unit, which is the derivative, this is exactly the same. You just do it again. The derivative of the derivative. And you could do third derivatives, which is derivative of the derivative of the derivative, if you wanted. But is it any harder than anything else that we've done? No. You just have to do something 2 times in a row. Okay? Is it important? Yes. We have applications that use the second derivative. In your next unit, which is applications of derivatives, you need to use the second derivative often. Why is Leibniz notation the way that it is? Because remember this notation? This means do the derivative of that, right? So if you did the derivative twice, do the derivative of that, can you see that you would have the d twice and the dx twice on the bottom? And this is your function y. So the notation kind of makes sense. Okay, a little bit lazy that they didn't put brackets around the bottom, but that's technically what they mean. Dx squared, the whole thing is squared. And the reason the squared is after the d, because you're doing the derivative twice of the function y. So that's possibly why the notation is the way that it is. Okay, so, wow. Find the second derivative. So what do? You find the first derivative. And then after you found the first derivative, you find the derivative again. The second derivative. Is it kind of nice to end a unit with something that is straightforward? Yes? No? No? Now you're disappointed. You were hoping your mind would get blown on the last lesson. You're good? You sure? I could probably pull up something really complicated and ruin you for a day. No? It's all good? I'm kidding. Sometimes when we have to do the second derivative, our first derivative complicates our second derivative. It is a chain rule. Good observation. So you do your chain rule, and then you may take some time to simplify it just because it might make things easier moving forward. So yes, for our first derivative, we needed the chain rule. We had a function inside of another function. What rules do you need for your second derivative? Just a regular one?
Oh, that's not. I thought you were asking. But yeah.
What rules are we going to have to use? Because there's our first derivative, simplified, 6x minus 9 times x squared minus 3x all squared. We're going to need product rule and the chain rule again. There we go. Product rule. Keep the first one the same. Derivative of the second one, which when you do the derivative of the second one, it has a chain rule. Plus, keep the second one the same. Derivative of the first one. No need to simplify. There's your second derivative. So example 3 and example 4 are just finding second derivatives. I'm going to give you 5 minutes to get done as much of them as you can. And then I'll show you the answers for 3 and 4. Probably not enough to finish them, but if you want to look at the answers later on the video, you'll be able to. Then we'll take a minute to finish example 5, and then you have 15 minutes to work on your take-home quizzes. Okay, no need to simplify. Good. And B. Good. Could leave it just like the first one. Oh, I didn't do the second derivative for the first one. There's our first derivative. Here's the second derivative. Sorry. Yeah, if you want to take pictures of them, whatever. Second one, here was the first derivative. Then it's a quotient rule. There's your second derivative. C, product rule for your first derivative. I took the time to factor it out. And then product rule again for the second derivative. D, product rule is chain rule for the first derivative. And then just chain rule, or sorry, no product rule, just chain rule for the first one, just chain rule for the second one. Question 3, easy rules for the first one, easy rule for the second one. This one you probably don't even need to look at. You can just get it easily later. Only difference in question 5 is it says find f double prime of 1. What does that mean? That means you're going to have to plug in 1 once you find the second derivative. So first derivative, chain rule. Second derivative, chain rule. Plug in 1. 16e squared to 3 sig figs, approximately 118. So I was talking to Mr. LaFrance. We're trying to figure out what's best. We have a couple of options. Okay. Option 1 means that you start your next calculus unit in second semester when you get to Mr. LaFrance's class. Oh, I don't need to record options.